Imagine asking your company's, I don't know, $1 million AI assistant for a simple software update, and it just cheerfully hands you the keys to a ransomware gang.
Yeah, I mean, that is literally what we're looking at today.
Right. Welcome to the deep dive. Today's stack of intelligence reports is just a massive wake-up call. We are looking at 3 breaking cybersecurity reports from late May 2026.
And they all really point to this overarching theme, right? This fundamental shift in how threat actors are operating right now.
Exactly. They aren't even bothering to batter down your digital front door anymore. Instead, they're bypassing that door entirely. They're weaponizing the platforms, the code vaults, and like I mentioned, the new AI assistants that we inherently trust.
Is a critical shift in tactics. I mean, it really requires us to rethink our entire defensive posture.
Right.
Because the reality of today's threat landscape, it isn't just about hackers breaking code anymore.
Right.
It's about them breaking our assumptions of safety. We build all these enterprise workflows around these tools, assuming a basic baseline of security.
We assume the code repository is locked.
Yes, exactly. We assume the enterprise document server is checking for malicious activity. We assume the chatbot is giving us legitimate links.
And these reports show exactly how those core assumptions are just being systematically turned against us.
They really do.
And, you know, whether you are a software developer pushing code, an IT admin managing a corporate network, or just someone sitting at home asking an AI chatbot for a hardware recommendation, these vulnerabilities directly impact your daily digital life. You are the target of this shift.
Absolutely. No one is really insulated from this.
So let's get right into the first report, which we can kind of look at as the broken lock on the private vault. This is a massive vulnerability in Gitea.
Right, Gitea.
Now, for those who might not live in this specific tool every day, Gitea is a hugely popular open-source, self-hosted platform for version control. It is where developers store their code, their digital blueprints.
It's the crown jewels for a lot of organizations. Yeah. And the flaw here is tracked as CVE 2026-27771, discovered by a UK-based security company named NoScope. The core issue is just staggering. Anyone on the internet can pull private container images without an account, without a password, or any prior access.
Which is wild.
It's like a bouncer rigorously checking IDs at the front door of an exclusive club, but completely ignoring the massive open loading dock in the back.
The loading dock analogy is, it really hits the exact technical failure here. Because when operators set a container repository to private in Gitea, they reasonably expect the software to enforce that boundary across all avenues of access.
Right, across the board.
But the authentication check was entirely missing for the container registry endpoint.
Wait, entirely missing?
Completely.
Yeah.
See, security audits often focus heavily on the web interface, you know, the obvious front door where users log in and click around.
But modern DevOps tools rely heavily on APIs to communicate machine to machine. So the developers wired up the authentication middleware to the web routes, but they simply missed attaching that same security checkpoint to the specific API endpoints handling the container registry pulls.
Oh, wow. So if a machine asked for the data, it just handed it over.
Pretty much.
And because of that missed checkpoint, this flaw went completely undetected for nearly 4 years.
4 years. It's really hard to wrap your head around.
4 years of an open loading dock on an open source platform that, you know, relies on the whole many eyes make all bugs shallow philosophy.
Right, the open source promise. But clearly, no one was looking at the API routes.
Yeah. And the impact here is sprawling. I mean, NoScope estimates this affects over 30,000 deployments across more than 30 countries.
Yeah, I saw heavy concentrations in China, the US, Germany, France, and the UK.
Exactly. And if you're listening and thinking, oh, well, this is just a tech company problem, the sources specifically note this spans healthcare providers, aerospace manufacturers, retail infrastructure, and even internet service providers.
We are talking about critical infrastructure, exposing their private containers to the open internet.
Yeah, which is terrifying.
It is, because those private containers are absolute gold mines for threat actors. I mean, they don't just hold compiled applications. They often hold proprietary source code, hard-coded API keys, database credentials, or internal network configurations.
The stuff you really don't want getting out.
Right. So if an attacker pulls that container, they aren't just stealing intellectual property. They are essentially downloading a detailed map of your internal network and the administrative keys to unlock it.
So they can just open it up and find what they need?
Yeah. They reverse engineer the container to find a database password and then use that password to pivot straight into the live production environment.
Which means the remediation for this isn't just, you know, patching the software.
No, not at all.
It's rotating every single credential that might have been stored in a vulnerable container over the last 4 years.
That is a massive headache for IT teams.
A total nightmare. And speaking of patching, the vulnerability affects versions of Gitea prior to the 1.26 branch, but the advisories have this really crucial versioning nuance.
Yeah, this is important to catch.
If you are scrambling to fix this, the sources advise updating to a specific 1.6.2 legacy branch for optimal protection.
It's an unusual numbering jump for sure.
It really is. It underscores how important it is to read the fine print on security bulletins rather than just, hitting update to latest and assuming you're safe.
Absolutely. And, if patching immediately just isn't an option due to, say, change management freezes or intensive testing requirements, there is a temporary workaround.
Okay, what is it?
You can alter the Gitea configuration file to tweak the parameter that requires a global sign-in view. The setting is require second view equals true.
Okay, that sounds simple enough.
It is, but there's a massive operational trade-off. It's a blunt instrument.
Oh,
Well, if you force global authentication across the entire view, it completely breaks any containers or repositories you intentionally wanted to expose publicly.
Oh, I see.
Yeah, your open source projects or public-facing documentation hosted on that instance will suddenly just demand a login.
So it just locks down everything.
Everything.
Man, so an open source moat failed because the door was missing entirely.
Right.
But what happens when the door is heavily guarded, but the guard is tricked into carrying the bomb inside themselves?
That is a great way to put it.
That's exactly what Microsoft just patched. Which brings us to our second source today. Moving from open source to enterprise, we have a major patch for a remote code execution, or RCE, vulnerability in Microsoft SharePoint.
And SharePoint is essentially the central nervous system for document management, internet hosting, and collaboration in countless enterprises globally.
It's everywhere.
It really is. So an RCE here is a severe event. This specific vulnerability is CVE 2026-45659 and carries a high CVSS score of 8.8.
And 8.8 is pretty bad, right?
Very bad. A score of 8.8 generally indicates that the flaw is network exploitable and has a massive impact on confidentiality, integrity, and availability. It was discovered by a researcher operating under the handle MEOW.
MEOW, classic.
And it affects SharePoint Server Subscription Edition, SharePoint Server 2019, and SharePoint Enterprise Server 2016.
Okay, so I am looking at the technical advisory from Microsoft, and if you are an IT admin listening to this, you might see the prerequisites and think, oh, I have some breathing room.
Because of the authentication requirement.
Exactly. The source says the attacker needs authentication, but they don't need administrator privileges. They don't need elevated access. They just need basic site member permissions.
Right, the lowest level, essentially.
So if SharePoint is so heavily guarded, how does someone with standard low-level access execute code remotely on the underlying server?
Well, that requires us to look at the underlying mechanism, which is the deserialization of untrusted data.
Okay, break that down for me. Deserialization.
Sure. In object-oriented programming, serialization is how an application packages up complex data structures, or object states, into a format that can be easily stored or transmitted over a network.
Like packing a suitcase for a trip.
Exactly.
Yeah.
And deserialization is just the reverse process. It's the server taking that packaged data and unpacking it, reconstructing the live object right there in its memory.
Okay, so it's like the server receiving a digital blueprint for a building, and instead of just, filing the blueprint away in a cabinet, it automatically starts constructing the building on its own property.
That is exactly the right framing. And deserialization vulnerabilities occur when the application blindly trusts the blueprint.
It just builds whatever it's handed.
Right. The server assumes that because the data came from an authenticated user, even just a basic site member who is allowed to upload documents, that the blueprint is safe.
And it's not.
No. The attacker constructs a malicious serialized object, essentially hiding a demolition charge inside that blueprint. When the SharePoint server deserializes the data, it reconstructs the object, and in doing so, it just executes the attacker's hidden instructions.
Oh, wow.
And the most dangerous part is that the server executes those instructions using its own system-level service account privileges, not the low-level privileges of the site member who uploaded it.
So the server basically detonates the bomb on itself.
They're sliced.
And because SharePoint is inherently collaborative, Any user who can interact with a list or upload a file can trigger this deserialization process.
Yeah, the attack surface is huge.
Now, Microsoft's assessment noted that this specific flaw is, quote, less likely to be exploited in the immediate term because it does require that authenticated baseline.
Right, they always try to temper the panic.
But if we look at historical context, relying on that assessment feels like a gamble. I mean, just last month, Microsoft had to issue fixes for a spoofing vulnerability in SharePoint CVE 2026 32201.
I remember that one.
Yeah, that one had a lower CVSS score, a 6.5, but it was actively being exploited in the wild.
It was. Historically, SharePoint flaws are repeatedly weaponized by threat actors, and often very, very quickly after a patch is released.
Why is that? Just the value of the data?
Exactly. The payoff is simply too high to ignore. If an attacker compromises a SharePoint server, they gain access to the internal documents, financial records, strategic plans of the entire company.
Everything.
Furthermore, because SharePoint servers are deeply integrated into the Active Directory environment, compromising one provides a perfect beachhead for lateral movement across the rest of the corporate network.
So the practical takeaway for you listening is clear. Do not sleep on this patch. Do not let that authenticated user requirement lull you into a false sense of security.
Definitely not.
Because it only takes one compromised intern's credentials to give an attacker the site member access they need to hijack the entire server.
That is all it takes.
So, synthesizing these first two reports, both the Gitea container exposure and the SharePoint deserialization flaw involve attackers finding and exploiting structural flaws in the software's actual code.
Right. Traditional vulnerabilities.
But what happens when the attackers stop hacking the code and start hacking the modern user's trust in AI?
Now, this is the really interesting one.
That leads us to the third and honestly most complex source in our stack today.
This is a fascinating pivot in threat actor behavior. It's detailed in a new report from Microsoft Defender experts. We're looking at a highly active cryptojacking campaign that leverages AI chatbots to deliver complex malware payloads.
AI chatbots.
Yeah, and it demonstrates a deep, deep understanding of target demographics. They aren't blasting this out indiscriminately.
No. Who are they targeting?
They are specifically targeting users with high-performance GPUs, impersonating legitimate system utilities like HW Monitor, Crystal Disk Info, Firmark, and PDF Gear.
Oh, utilities that gamers or PC enthusiasts use. The logic there is pure financial efficiency. I mean, if an attacker wants to mine cryptocurrency, infecting 1,000 basic office laptops isn't nearly as profitable as infecting 100 high-end gaming rigs or workstation rendering machines.
Right, you want the heavy iron.
But the delivery method is what makes this a watershed moment. Historically, we've seen SEO poisoning, right? Where attackers game Google search results so their fake download site appears at the top.
A classic trick.
But here, they're gaming large language model tools. Users are querying these AI chatbots for software download recommendations, and the AI is feeding them direct links to attacker-controlled domains.
It's completely wild.
You trust the AI to summarize the web and give you the right link, and it just unwittingly hands you malware.
Yeah, and the domains they are routing users to, such as glees.com, which is hosted via the dynamic DNS provider, they feature these prominent, legitimate-looking download buttons.
So it looks totally safe to the user.
Very safe. And the technical execution from that single click is incredibly sophisticated.
Walk me through it. What happens when they click?
So the download a ZIP archive contains a legitimate, signed executable for the software the user requested.
So the actual program is in there.
Yes. But hidden alongside it is a rogue DLL file, specifically named autorun.dll.
Which initiates a classic sideloading attack.
Precisely.
So the user clicks the save file, but the operating system behaves in a way the user doesn't anticipate.
Yeah, because Windows applications often rely on external libraries, or DLLs, to function. When the legitimate executable launches, Windows automatically looks in the local directory for associated DLL files to load into memory.
And it finds the bad one.
Right. It finds the attacker's rogue autorun.dll and seamlessly sideloads it into the trusted application's process space.
Sneaky.
Very. And that rogue DLL then installs a second malicious file, vcredist by 64.dll, which unpacks and installs Screen Connect.
Oh man, Screen Connect. That is a legitimate remote desktop application used by IT departments all over the world.
Yes, it is.
And this is where the threat goes from a nuisance to a catastrophe. Because this isn't just about cryptojacking anymore. By silently installing Screen Connect, the attackers establish persistent remote administrative access to the compromised host.
They own the box.
They completely own it. They are phoning home to an attacker-controlled server at a specific IP address, 193.42.1my108.
Yeah, I saw that IP in the report.
So the crypto mining is almost just the noise, right? It's the immediate monetization strategy, while that Screen Connect backdoor is the real strategic beachhead for data theft or deploying network-wide ransomware.
Exactly. And even the deployment of the crypto miner itself is deeply stealthy.
How so?
Well, this Screen Connect session serves as a conduit for another executable called simplerunpe.exe, which utilizes a technique called process hollowing.
Process hollowing, that sounds awful. What is that doing?
It is a masterclass innovation, honestly. The malware takes a trusted Microsoft-signed binary and launches it, but in a suspended state.
So it pauses it before it can really start.
Right. Before the legitimate code can execute, the malware hollows out that memory space, unmapping the safe code.
Like scooping out the insides.
Yes. It then injects its own malicious crypto mining payload. And it supports miners like JewMiner, LolMiner, and SRBMiner multi-I. It injects that into the empty shell, modifies the execution registers, and resumes the thread.
Wow. So if you open your Task Manager, the operating system sees a perfectly normal, cryptographically signed Windows process running.
Exactly.
It's just wearing the skin of a trusted application.
It is. And it actively defends that disguise, too.
Really? Yeah.
It configures Microsoft Defender exclusions, so the local antivirus just ignores the mining activity.
Of course.
Furthermore, it constantly polls the system for analysis tools.
Like checking if you're looking at it.
Yes. If the user opens Windows Task Manager, Process Hacker, Plus Explorer, or System Informer, the malware immediately terminates the hollowed miner process to stay hidden.
So it plays dead.
It plays dead. It waits until the monitoring tools are closed before it starts stealing your GPU compute power again. It is an automated cat-and-mouse game happening entirely in the background.
That is just brilliant and terrifying, and this theme of wearing the skin of trusted tools ties perfectly into the second half of that Microsoft report, which expands on how attackers are living off the land within corporate environments.
Right, the incident with the Edge appliance.
Yeah. The Defender experts detailed a separate incident where an unknown threat actor compromised an internet-facing F5 BGIP Edge appliance.
And for context, an Edge appliance sits right on the boundary between the wild internet and the internal corporate network. It routes traffic, balances loads.
Right. And the attackers compromised that appliance, but instead of dropping noisy custom malware that would trigger an endpoint detection and response alert, they abused trusted relationships to pivot to an internal Linux host.
They just blended right in.
Exactly. From there, they utilized tools that were already installed and inherently trusted by the environment. They set up a custom FTP server using Python's built-in ftplib module.
Which is so clever because Python is ubiquitous in enterprise environments.
Exactly. IT admins use Python scripts constantly for automation. An EDR platform isn't going to automatically flag a Python library running on a Linux server because it looks exactly like normal administrative behavior.
That is the brilliance of living off the land. You hide in plain sight. They use that Python FTP server to transfer a custom network scanning tool, move laterally to a vulnerable Atlassian Confluent server, and eventually obtain credentials to conduct Kerberos relay attacks against the Active Directory infrastructure.
Let's pause on Kerberos Relay for a second because it is a devastating technique if you are managing a Windows domain.
Yeah, it is.
Kerberos is the authentication protocol for Active Directory. It relies on tickets. It's like a valet system. You hand your keys to the server, and it gives you a ticket to prove who you are. In a relay attack, the threat actor intercepts that ticket on the network. When a highly privileged machine tries to authenticate to the compromised Confluent server, the attacker catches that cryptographic proof and relays it to a completely different, higher-value target.
Like a domain controller.
Exactly, essentially telling the network, hey, I'm this trusted domain admin.
It completely subverts the authentication perimeter.
Just entirely bypasses it.
And they didn't stop there. They exploited another flaw, CVE 2025-33073, to compromise a SOS application and maintained access to a Linux server over SSH using a privileged account.
So they were everywhere.
Everywhere. And throughout this entire intrusion lifecycle, they never established explicit, noisy persistence mechanisms, like registry run keys or scheduled tasks that defenders normally hunt for.
They just look like a highly privileged system administrator doing their job.
Exactly.
So whether it's dropping Screen Connect via a hallucinated AI chatbot link, or hollowed out Windows processes mining crypto, or using Python's ftplib to pivot through an internal server, the unifying theme of the day is camouflage.
That is the absolute core takeaway from all of these intelligence reports. Threat actors are anchoring themselves in environments and workflows that appear compliant on the surface.
They look like they belong.
Yeah. They are exploiting third-party IT providers, edge appliances, and AI chatbots specifically because we explicitly trust those things. We just don't scrutinize the tools that are supposed to be helping us.
We just let them run.
Right. And Microsoft's advice here is paramount, and it represents a necessary cultural shift in IT management. Defenders must adopt a posture of deliberate verification.
Deliberate verification. You cannot just set your perimeter and forget it. You can trust your vendors and your enterprise tooling, but you must validate their behavior within your environment continuously.
Continually asking questions.
Yes, you have to ask, why is this hardware monitor suddenly establishing an outbound Screen Connect session to an unknown IP?
Right.
Why is this internal Linux server running a custom Python FTP script to a Confluence server? You cannot assume validation just because the tool itself has a digital signature.
It requires behavioral monitoring, not just signature-based detection. You have to understand what normal looks like in your environment so that when a trusted tool starts behaving abnormally, you actually have the visibility to catch it.
All right, let's bring this all together and give you, the listener, some clear, practical takeaways to action today. First, if you are managing enterprise infrastructure, prioritize the patch for the SharePoint RCE flaw.
Absolutely. Do not wait on that one.
Even if you think your internal users are safe, deserialization vulnerabilities are incredibly dangerous. It only takes one compromised site member to detonate that digital blueprint.
Just one.
Second, audit your Gitea containers. Check your version immediately. If your deployment is prior to the 1.26 branch, examine the update paths to that 1.6.2 legacy branch, or apply the configuration workaround if you do not rely on public-facing repositories.
Lock down that loading dock.
Yes, close the loading dock. Third, adopt that mindset of deliberate verification for your edge appliances. Monitor what your legitimate tools are actually doing on the network.
Look at the behavior.
Exactly. And finally, on a personal operational security level, do not blindly trust the download links handed to you by an AI chatbot. Verify the domain yourself before you click download.
Yeah, if I can leave you with one final thought to mull over regarding that AI chatbot campaign.
Please do.
We spent a lot of time discussing how the malware is delivered, but consider the mechanism of the AI itself. We know that these large language models are continuously scraping the internet and ingesting user interactions to learn how to answer our questions better.
Right. They are always learning.
But we now know that attackers are successfully poisoning that learning pool. They are actively manipulating the model to serve malicious pathways.
Which is just wild to think about.
It is. So at what point does an AI, which relies on a consensus of data to determine what is true, become a permanent, unwitting accomplice in social engineering?
Wow.
And more importantly, once an AI has ingested enough manipulated data to learn that a malicious link on Glees.com is the definitively right answer to a user's prompt, how exactly do you unteach it?
Man, that is a fascinating and terrifying problem for the future of digital trust. Thank you for joining us on this deep dive into the shifting threat landscape. We will be back with more insights next time.